Greetings and welcome to my new calculus channel once again. And today I'm going to be talking about something I've talked about before, but a few people have asked me to explain a little bit more. So that is the concept of an abstract unit. Now if you, for example, type in Google or whatever other search engine you have, what is the abstract unit in mathematics, you'll get a whole lot of irrelevant, unrelated stuff. For example, it'll talk about a unit in abstract algebra, which is not typical algebra to begin with, and it'll give you things about abstraction, what are they, etc. But you have to come all the way down to the free dictionary to see the closest or the best definition, which is one taken in the abstract. But what does that mean? The number represented by one. Okay, so you've heard it being said over and over again by your ignorant and incorrigibly stupid professors of mathematics and teachers that the natural numbers came first. That is absolute rubbish. Okay, now what I'd like you to do is I'd like you to download or go to academia.net, and I'll place a link, and you can copy the ultimate book of numbers and look at chapter 3 where I explain the abstract unit. Okay, so I'm going to give you a quick rundown of what it is. So now, for example, in geometry you have a fixed size unit. Now suppose that's a straight line and it has a fixed length, right? But you can have any unit that you'd like to use for measurement. Now in algebra, for example, let's say we've got an isosceles triangle like that, okay, with these two sides equal. And in geometry we talk about this diagonal. So I'm going to call that D, and I'm going to call this U. And so in geometry we can refer to that as du. But what does algebra do? Algebra doesn't actually deal directly with the ratio anymore. It deals with the measure of the ratio. So algebra does this. It says the measure of du is root 2. Of course that's not true, because root 2 is not a number, it's a constant. So, and of course you can't say that this is a unit, because the abstract unit doesn't care about size. You could have a right angle triangle that big, and again, if you use this side to measure the diagonal or the hypotenuse, it'll go in once and a little bit. Okay, so you can see that in geometry it goes in once and a little bit, right? And a little bit. In other words, exact measurement in geometry, and you can describe it exactly in geometry by saying it's the ratio d to u, or just this line length to that line length, okay, where this little part is longer than this line here, okay, and you express that exactly in geometry. You cannot do the same thing in algebra. Okay, so algebra is a weaker form of geometry which deals only with the abstract units. In other words, it doesn't care about the size of the unit or even the type, because I mean you could be referring to this mass, whatever it is, compared to this mass, right? Algebra doesn't care about the type. It only cares about the abstraction, the measure, in other words. So if you had to take the measure, that's what you get. So for example, to get the first natural number, you could just take a line, the ratio of a line to itself, right? These are equal distances, and you can call that the measure of that 1, right? So this here is your abstract unit. Okay, that's your abstract unit. Then using the same length, you can do this, put two of them together like that, take the measure of that, and that's 2. And 2 is the next number, okay, because here you've got the abstract unit, and now you know that 2 is the increment of 1, okay? So it's basically just a case of realizing that you use measure in algebra. Okay, not the typical bullshit that you find in calculus courses such as Lebesgue measure or set theory measure. That's all garbage, and your lecturer is a moron. So just don't pay attention to that. So this is what is meant by abstract unit. And the same thing happens, by the way, when you have, let's just reset the canvas. For example, when you have a circle, right, and a diameter, you use, so in geometry, all the operations of arithmetic are 100% accurate in this order: subtraction, addition, division, and multiplication. And they're all done exactly the same way, regardless of whether the line length is a fraction or a whole number or anything. And you can find out more about that in this fantastic publication of mine called The Ultimate Book of Numbers. So I'm not going to spend time with that. But coming back to this diagram here, we use the diameter as a unit to measure the circumference. So we say, okay, it goes 1, 2, 3, and a little bit. So we know that this little bit can easily be taken off the diameter, and we have an exact measure in geometry, not an exact measure, but an exact representation, and we can use it in arithmetic exactly. In other words, to 100% precision. That's also explained in my article. But so when you say in geometry, when you want to represent this ratio in geometry, and I'm getting iPay again, it's the circumference to the diameter, and the diameter acts as the measuring unit. Okay, so if we unfurled the whole circumference in geometry and the diameter, we'd have something like that. But algebra doesn't care about this, because I mean, you could have a bigger circle, in which case you'd have a longer circumference and something like that. Okay, so the number, there's no number pi. That's absolute rubbish. Pi is not a number of any kind, and it doesn't exist either in theory or in practice or in any other sense. Pi is the constant that is realized from attempting to measure the circumference using the diameter as unit. And what we realize each time is that we get a constant 3.14159, and we don't know the whole thing. So basically all we ever have is really a rational number when we talk about pi. Of course, pi, this ratio here doesn't have a measure, so pi is really not even a magnitude. It's not a magnitude, it's not a number, it's a failed measure. It's an attempt to measure the circumference using the diameter. Okay, and that is what algebra is all about, by the way. It's a weaker form of geometry. In geometry, you can perform all these operations, and I'm repeating it, exactly to 100% accuracy. How? And you can see by looking at my YouTube channel, where I talk about the symmetry of the circle. Okay, and I'll show you how all these operations are performed. It's a great presentation, great video. It's called Symmetry of the Circle. So I think I'm going to have to stop now. That's what an abstract unit is. It's simply the measure of two magnitudes which are equal, okay, and assumed as the common consequence, the common consequent of a ratio. So, for example, here in this circle here, we assume D is the unit. In a bigger circle, we assume this D is the unit. But in algebra, it doesn't matter, because both of them are abstract. The algebraic unit does not care about the size or the type. Okay, so I'll put a few links in the details section. Please find it in your heart to donate some money to me. I am not exactly wealthy, and I'm actually not earning anything from these videos on YouTube. I'll place a link to a GoFundMe page where you can spare a few dollars. I'm not begging you, you don't have to do it, but it would be nice if you could donate a few dollars. And that's pretty much it. My name is John Gabriel, and this is a New Calculus channel. Till next time, goodbye.